Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers. So that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount. So we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now, it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, okay, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25. Should be here. And then across, and that's how we would make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this. but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is minus 31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so minus 30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be minus 1 equals c. So c is minus 1. So we now know that the equation is y equals minus 2x minus 1. And we're told that the y is minus 37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be minus 36 equals minus 2x. I'm going to now times, or divide everything by minus 2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. So first thing to realise is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497,069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same. So we're going to keep that as the volume, 1497069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared. And we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. We don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that will be 141.11. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half a plus b h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount, so we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence. So I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160. Take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. To convert from meters to centimeters, we times by 100. But here we're asked to convert between meters cubed and centimeters cubed. So we times it by 100 per dimension. Meters cubed and centimeters cubed is volume, which is 3 dimensions. So what we do is we times it by 100 3 times, times 100, times 100, times 100, or times by 100 cubed. So we get our amount, 0.15, times it by 100 cubed, and that will give us 150,000. So our answer is 150,000 centimeters cubed. To find the area of a quarter circle, we first of all just assume that the circle is whole, and we work out the area that it would be if it was a full circle. So the area is pi times r squared. The radius will be this distance here, which is between the centre and the circumference of the circle. So it's going to be pi times 22 squared. And when you do that on the calculator, you get 1520.530 blah blah blah. I'm going to keep that into my calculator because we don't have a full circle, we only have a quarter of a circle. So if we're looking for a quarter of a circle, what we want to do is we want to divide that area by 4. So the area of the quarter circle is going to be the 1520.530 blah 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 divided by 4. So you keep it in your calculator from before and just type in divided by 4, and we get 380.132 blah blah blah. It says it wants it to 2 decimal places, so we're just going to round that to 380.13. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. First thing we notice with the simultaneous equations is the coefficient of the x and the coefficients of the y are different, so we need to make them the same. I'm going to focus on the y's, I always do, but you could do this with the x's. So we've got a 3 and a 5, so the lowest common multiple of 3 and 5 is 15, so we need to make them both to 15. So we're going to start off with the 3x plus 3y equals to 15, and get our lines in, because what we're going to do is we're going to times everything by 5 to make that second one 15. So we are going to have 15x plus 15y, and then 15 times 5, which is 75. Going to do the same with the second equation, so 4x plus 5y equals 23. Get our lines in. This time we're going to times everything by 3. So we've got 12x plus 15y, which was the whole point, and 23 times 3, which is 69. So we're going to write those equations again next to each other, so we can do our simultaneous equation magic on them. So with simultaneous equations, we're working down the page. So we put these little circles in to show the direction that we're working. And we're either going to add or subtract. And to find out which, we look at the signs before the coefficients we made the same, so before the 15y's. And if they are both the same, then we are going to subtract. If they are both different, we are going to add. So the S in same is the S in subtract, the D in different is the D in add. Well, you can see here that they are both the same, they're both pluses, so we're going to subtract. So we're going to subtract going downwards, and we've got 15x take away 12x, which is 3x. 15y take away 15y, which is nothing, which is good, that's the whole point. And we've got 75 take away 69, which is 6. Is it 6? Yeah. Okay, so we're going to then solve that. So we're going to divide by 3 both sides to get what x equals. And so x equals 2. Now that's only half the battle because we need to find out what y equals. So we're going to substitute that into the first equation. And so we've got 3 times 2 plus 3y equals 15. Now 3 times 2 is 6, so we're going to take away 6 both sides. So we've got 3y equals 9. And we're going to divide both sides by 3, so y equals 3. And we can check that by substituting it into the second equation, so 4 times 2 plus 5 times 3, and that does equal 23. It's sometimes easier in these questions to view these triangles as 2 separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got 2 triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the 2 triangles are similar because the sides here we assume are, well, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A, and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20. And then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So we're going to start off by finding the multiplier, and we start off with 100%. It's an increase of 3.4%, so we get increase 3.4%, and so that would be 103.4%. And then we need to make that a multiplier, so we're dividing it by 100. And so that would be 1.034. So anytime we times a number by 1.034, we'll increase it by 3.4%. So it says that we start off with 1,700. So what we're going to do is we're going to type in 1,700 into our calculator, then we're going to press the equals button. And what that does is it stores the 1,700 in memory. Then, every time we press the ANS button, it's going to remember what the current number is, and we're going to then times that by 1.034. So at the moment, the current number stored in memory is the 1,700, times by 1.034 will increase the 1,700 by 3.4. Press it once, and it gives us £1,757.80. Now, when we press it again, that would be after the second year. So it puts in the 1,757.80, it puts that in as this answer here, and then raises that by 3.4%. So we've got to keep pressing equals and count how many times we press equals to get to £1,743.26. And you'll find that on the 4th press of the equals button, you will get £1,943.26. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3/5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3/5 times 2/4. And I realise I could cancel 2/4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2/5 times 3/4. So 2/5 times 3/4, 3/4. That would be 6/20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6/20 plus 6/20. And this is the probability of different. Which will be 12/20. Now 12/20 will cancel to 3/5 or 3/5. So this says find the probability of A or B. Now A or B means it can be in A, it can be in B, or it can be in both. So we add the 5, the 3 and the 12 together, and that gives us 20. And put that over the total amount. So that is these 3 added together, which is 20, plus the one outside here, which is 30. 20/30 is the same as 2/3. So vectors are shown with how far right at the top and how far up at the bottom. So we've got -3 right, which is actually going to be 3 left, and -2 up, which is actually going to be 2 down. So to start this off, what we're going to do is just put a point anywhere on this grid. And we're going to go 3 right, so 1, 2, 3. And we're going to go 2 down, so 1, 2. Let's show that point there. And then all we need to do is join up these 2 points with a straight line. And we need a direction. So we actually started at the top right one and went to the bottom left one. So the direction is going to be this. And it says it's vector A. So we're just going to label it with an A. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here. And basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. that's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. We're asked to solve this quadratic, and we're told that we're going to leave the answers to 2 decimal places. So chances are we're using the quadratic formula. So for the quadratic formula, we're going to use a, b, and c. We'll go find a, b, and c. A is the coefficient of the x squared. Now, we don't actually have a number before the x squared. Well, we kind of do. There is a 1 there, we just don't bother showing it. So a is 1. B is the coefficient of the x, which would be minus 15. And c is the number left over at the end. We're going to write down the quadratic formula, but instead of a, b, and c, we're going to feed in the values that we've got. So it's minus b. Always put them into brackets. Plus minus square root of b squared. So I always put a, b, and c into brackets, because here if you don't have the brackets it will square the 15, then put a negative before it. It won't be correct. And I just put brackets for each of the numbers. So 4 times 1 times 6, because if you put brackets around all of them you'll never ever have that problem. And then 2 times 1. Put that into our calculator with a plus there, and you will get the answer of 14.588 blah blah blah. Go back on your calculator and change that to a minus. Most calculators have cursor keys. You can go back and delete it and change it, and you get 0.411 blah blah blah. So to 2 decimal places our solutions are 14.59 and 0.41. So we can see that there are 8 squares in the first bar, and that represents a frequency of 4. So if you look at what we do to get from 8 to 4, or 4 to 8, we obviously times it by 2. So we're going to do that to the other frequencies. We're going to times them by 2, and they'll tell us how many squares we'll need. So we'll need 20 squares and then 12 squares. The width of the next bar is 10, and we are looking for, well, if you look at it in squares, it is 1, 2, 3, 4 squares wide, and because we need 20 squares in total, it's going to be 4 by 5, so it's going to be 5 squares high. So up here, I'm going to try and pick a colour that shows up a bit better. There we are. And we've just got to make sure that there are 20 squares inside here, which there are. And the last one has to be 12 squares, and it's going to be 2 squares wide, so it's going to have to be 6 squares high. And that will give us our 12 squares. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier. And we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. We're going to start off this question by finding length BD, and we do that by doing a little right angle triangle down here. And let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tram lines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same. So therefore, point A will be exactly at the midpoint or above the midpoint of the square. So M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. I'm just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5, and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared, and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tram lines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330. And because it says 2 decimal places, we want to write down the answer 4.33 centimetres. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.